Cybersecurity for the people. Professor Black Ops. We back at it, hitting them STIGs. We're gonna keep going over them. I'm actually gonna make a list in there where all the STIG checks are together in one list, so you can go through them all. So I'm still working on that. So we're gonna go over Oracle WebLogic. It's a very enterprise web server that's particularly popular, especially in DoD and the government. We'll talk about a little about DISA STIGs. Of course, we're going to talk about zero trust, zero knowledge. We're going to talk about encryption, where the traffic should be locked down. We're going to look at an AWS diagram of implementation, what they set up. Of course, the manage is the STIG part. Blue team, we locking it down. So let's get at it. WebLogic server is a centralized application server such as a web server, functionality, business component, access to backend enterprises. It uses technologies such as caching, connection pooling, improving resource use, and application performance. Once again, it's an enterprise web server. So it's a lot easier to patch. Oracle puts out quarterly patches for security. And of course, if there's a big security issue or vulnerability, Oracle will actually patch that a little earlier. Of course, it costs and it's a little expensive, but you get support, so you get timely security patches and everything. So this is WebLogic security. You got customer applications, WebLogic containers, WebLogic layer products, resource containers, protocol handlers, and WebLogic security. You get WebLogic security service, WebLogic security framework, security providers, interfaces, and security providers. A lot of interfaces when you connect to things like service buses, JDBC connections, web service calls, SSL service calls. So a lot of that stuff has built-in security that's excellent. It's not bolted on. It's actually baked into the Oracle or jar files. Okay, once again, this is the STIG. While the National Institute of Standards and Technology, NIST, provides guidance across the federal government, the Federal Information Act, FISMA, provides guidance for civilian agencies. Department of Defense Systems has yet another layer of requirements propagated by Defense Information System Agency, DISA. The federal IT security pros within DoD comply with the technical testing and hardening frameworks known by the acronym of STIGs, or Security Implementation Guidelines, according to DISA, are configuration standards for DoD information assurance and enabled devices and systems. The STIGs contain technical guidance to lock down information systems or software that might otherwise be vulnerable to a malicious computer attack, right? So you're talking about nation states types of attacks. So they have a plethora of settings to lock down your environment. So we're going to look at the locking down the Oracle WebLogic environment. So I think I looked on there with 72 STIG checks, 4 highs, 49 mediums, and 19 low checks, right? So high are high vulnerable systems that with a high impact and high risk. So we're just going to go over those 4. I have a lot of them actually in the description box. I usually cut and paste all the highs and a few mediums in the description box. So they'll be in there. So let's go over there. Vulnerability code 56277 high. Oracle WebLogic must uniquely identify and authenticate users or process acting on behalf of the users. To ensure accountability and prevent unauthorized access, application servers must be uniquely identified and authenticated. The application server must uniquely identify and authenticate application servers using process acting on behalf of the users via user store, while local OS based or centralized LDAP in nature, right? So you can actually use the OS to authenticate or go into a centralized LDAP. Of course, one of the most popular ones are Active Directory. So it actually has Active Directory's 2 connectors. So 56279 high. WebLogic must authenticate users prior to group authentication. To assure individual accountability and prevent unauthorized access, application servers and any process acting on behalf of the server users must be individually identified and authenticated. 56291. The WebLogic must encrypt passwords during transmission. Password needs to be checked at all times. Encryption is a standard method for protecting passwords during transmission. Vulnerability 56293. All Oracle WebLogics must utilize encryption and using LDAP for authentication. Passwords need to be protected at all times. An encryption standard method for processing passwords during transmission. Application servers' capability to utilize LDAP for authentication. If the connections are not protected in transmission, sensitive authentication credentials can be accessed. So once again, this is our classic architecture diagram. Web tier, application tier, and the database tier, standard 3-tier technology, right? So Oracle WebLogic could be in the application tier. So this is the standard, once again, the AWS. So once again, they have the 3-tier web server, application server, and the database tier. So that's AWS is zero trust architecture. So on this, right, the WebLogic will be in the application tier. Right there, auto scaling, connecting right to the database down here. So WebLogic is at the top. So you see it. That's a cluster configuration. So that's machine A, machine B, and machine C. That's the administration console, command line interface, JMX, and SNMP. That's the configuration XML there. So you have those two clusters there replicating between each other. So if B or C goes down, right, they continue to work. At the bottom, you see the JDBC connection. That's connected to the database, load balancer, and the firewall. So you come in here, you would go up to there to one of the cluster load balance. Then that cluster load balance would actually connect with JDBC through the database, right? So one of the checks I always do is make sure the JDBC connection is encrypted. A lot of web servers don't encrypt the JDBC connection. So part of the WebLogic is they have a database firewall. So if you see, all of those are actually databases: Oracle, Microsoft, Sybase, or IBM DB2, which was a known database in the 90s. So Oracle has, in part of the WebLogic, they have a database firewall. So as the traffic comes through to your database, the database firewall will look for certain JDBC connections. You can actually give it a pattern out of all your select statements. So you can only say select statements coming from WebLogic to get back there. It would have to meet this pattern of the select statement to get back there. Right, so if a hacker got in there and they try to do some other select that wasn't in your patterning matching, or down here they call it policy. If it didn't see a policy that for that particular insert, update, or select that your code was generating, it would actually block that. So if you had an intruder and they came through and hacked your WebLogic, but they were trying to query the database in a different format, the database firewall will actually block it. So part of that database firewall is called microsegmentation. Trying to have a firewall over every resource or device to make it a lot harder for nation states to get in there. So just want to hit that at the high level. Down here, data encrypted firewall, web server, and logic. So here you see the client coming in through a standard firewall with the browser. We have a web server with the WebLogic plugin. So you can actually run Apache with a web server plugin. And once you get there, to go back there with the actual WebLogic console with the web app code, that's the WebLogic server. So that plugin would send specific calls to the WebLogic to make sure that code. And there you see the certificate. Right there, the certificate actually validated that call was for that particular WebLogic server. Right, so once again, this is part of Zero Trust. We're using microsegmentation because we got extra firewalls and we got one web server. Of course, we probably will have a cluster in case one goes out, but they will all have that plug-in and that particular certificate call to make sure that the call actually came from a web server that we control. Right now, the attacker could actually hack into that web server, but if they try to go around the client and go straight into the WebLogic server, it would be blocked because their card wouldn't actually have that certificate in it. So that's part of the zero trust, is extra security checks. So this is the AWS setting or architecture for zero trust for WebLogic. So up here you have the client, Salesforce Windows. You come into the JMS traffic, or over here the HTTP traffic. You go to a load balancer. That load balancer will go to the AWS Elastic Load Balancer. That will hit the right here is actually the Oracle WebLogic server, the SOA architecture. So once it hits the WebLogic server with admin serving the security there, right, it has to be encrypted, certain encryption key. Then that WebLogic server will actually call the Oracle database right here. So that's the 3 tiers, right? So you got the Elastic Band, you got the web server with the plugin going directly to the Oracle WebLogic, going to the database, right? So we have multiple tiers. We would have firewalls between those controlling the traffic, right? Then we also have the elastic load balancer, right? So it can scale up or down as part of that. So that's in there. So that lets you know AWS actually supports the architecture. It actually supports it in a zero trust way, because those WebLogic servers, we can actually have OS firewalls on those particular servers. Of course, for me would be Linux. So I actually can run the IP tables in Linux for a local firewall to actually submit to the actual zero trust and microsegmentation. So that's it at a high level. So we got that. If anybody wants those, just send me an email. Then I actually send those out if you want to see those slides. But once again, doing an AWS Zero Trust for Oracle WebLogic application web server. So that was just something short. I just want to touch on the STIGs. And once again, I have a lot of the STIGs text in the description. If you got any additional information, just put it in the comment section and I'll respond. Once again, Professor Black Ops, cybersecurity for the people, getting at those STIGs.